Good morning. Welcome to the, I think, 12th Denver ISSA virtual event. And my name is Teresa Grote. I'm the Director of Membership for Denver ISSA. And we have been excited to bring all these different programs to you, incredible amounts of speakers and great information. And you get CPEs for watching these as well. So you can rack up the CPEs through this whole program, especially in June. We are going to be covering using big data tools to understand your cyber environment in just a couple moments. But before we start, I just want to give a shout out to our latest new sponsor, which is Zscaler. So thank you, Zscaler, for helping us to bring this wonderful education to people virtually. So I'm going to go ahead and introduce our speaker, Brad Rhodes. Brad is the head of cybersecurity for Zavilo, which is located in Greenwood Village, Colorado. He holds numerous professional certifications, including CISSP, ISSEP, CISM, PMP, CEH, RHCSA, and GIAC, to name a few. He has over 23 years of experience in the military, government, and private sectors. Brad continues to serve in the Colorado Army National Guard as a cyber warfare officer, leading the next generation of soldiers in today's cyber fight. In the last year, he has presented on cyber incidents response to over 1,000 emergency management personnel, helping to prepare the nation in advance of the 2020 elections. Brad's major research areas include open source capabilities to help organizations close gaps in their security, characterize these cyber operating environments, and gain visibility to stacks of data. He's been known to drown a few Lego people to illustrate the practical reality of cyber effects. I think that's very cute. So without further ado, Brad, why don't you take it away and tell us all about big data.
Great. Thank you very much, Teresa. It's great to be with you today. My name is Brad Rhodes, as Teresa mentioned, and we're going to talk a little bit about using big data tools to understand your cyber environment. And if you can imagine air quotes, bonus for cyber incident response too. I did some work many years ago looking at how to gonculate a whole bunch of data together and figure out an easy way to display it, especially if all you're given is data and you don't know what to do. And what I'd like to share today is some of the tips and techniques through some stories and some examples of how that works. And we'll go ahead and get rolling. So here's the outline, pretty straightforward stuff. We'll get to questions at the end. So definitely good and interesting topics here, and lots of ways to look at your data with multiple tools out there that are free or free-ish. We're going to look at some of them specifically so you get a feel for what those are. And I'm going to introduce a new one called Pandas Profiling, which is now a new favorite of mine. So here's my who is, pretty straightforward. Just a couple of notes. I'm the head of security at Zavilo. We categorize the web. I'm also in the Army National Guard as a senior cyber warfare officer, Military Cyber Professionals Association. I teach part-time at Regis University. I coach a cyber patriot team and have all sorts of fun with that. The new generation coming up is pretty amazing, and way too many professional certifications. And I've been on a number of podcasts. One of them is linked there for you in the presentation. So why are we here? So there's three words here that I've tagged out on this slide. Everything vulnerable data leaking. That's why they're colored, because everything on the internet today is really everything on the internet. You can put nearly everything on the internet today. You can put traditionals like laptops, servers, phones, you name it, those kinds of things. The Internet of Things, like my favorite things over there, like internet-enabled microwaves now, and internet-enabled toilets, and the new Samsung dishwasher that I put in my house that apparently has its own Wi-Fi access point that it wants to talk to my phone with. Everything like that. Everything else. It's cars, right? How many people have bought a car in the last few years? And then when you bring it home, it says, okay, you need to connect your car to the Wi-Fi. Well, that's because when you pull into the garage and your car connects to the Wi-Fi, it downloads the updates for the firmware on the computers on your car. So really, we can put everything on the internet, and that's pretty interesting and also scary at the same time. And that drives us to the question of, what do you really know about your cyber operating environment? Have you allowed things to be put onto your networks, whether they your home networks, be your work networks, etc., that you really know anything about? And how do you learn about that? How do you figure that out? What's an easy way to do that? And really, the thing that's challenged here is all the vulnerabilities. In fact, there was a recent vulnerability that came out the last couple of days where there's a low-level TCP/IP stack that is on most Internet of Things type devices that are probably in your house today that is either not upgradable or not easily upgradable and vulnerable. And then, of course, leaking. Are you leaking data right now? The challenge here is that, as we've seen in incidents such as the Mirai botnet and others, where you have Internet of Things devices or any device that has a specific set of firmware or hard-coded passwords, et cetera, they could be easily exploited to leak your data out onto the internet. And you may not even know it. And so what we want to look at today here is some free tools and some techniques that allow you to get into your cyber environment relatively simple with relatively easy data collection, so you hopefully sleep a little bit better at night. Because really all of this comes down to is having visibility. If you don't have visibility into your environment, it is really difficult to understand where you have issues or problems. So one of the things that we're going to start with is that cyber truly is big data. And I know that's a buzzword. I've got that. But when you look at the volume of data, the velocity of data, the variety of data, what we call the 3 V's of big data, in cyber, we have it in spades. According to Cisco, about a year and a half, 2 years ago now, we crossed over the zettabyte era. So we have zettabytes. That's a really big number. That's 1 billion terabytes of data transiting the internet on a daily basis. So that's volume. 5G is coming. It's going to be here before we know it. And oh, by the way, they're talking that it's a million devices per square kilometer. Crazy, right? Just a massive amount of data, a massive amount of devices, everything on basically a cell phone network. Variety, 5 billion things. And things is important here because things can be anything like we just talked about that's going to be in the internet by 2030. So you remember that whole thing, why we need IPv6? Well, guess what? We're going to outstrip IPv6 and be natting that here pretty soon. And so we're going to even have even more big data to deal with. And then volume and variety. And here we'll come to that small home network. I don't know about you, but I have, I don't know, way too many devices at my house that are connected to the internet. My wife keeps looking at me as to why I have stacks of laptops in my office, and my kids have their devices. All of that stuff amounts to a large amount of things on a home network that produces literally, and you'll see this here in a minute, millions of data points on a daily basis. And most people don't realize that that's the amount of traffic you're generating out of your own home network. And that's amazing. And then, of course, velocity, right? 1 gigabit speeds is pretty typical on many networks today, whether they're local area networks or if you got fiber or anything like that. So really, when you think about big data, cyber is the ultimate big data problem, as you'll see here as we go along. We have some big data tools that we can use to get at some of these problems. And I'll start with free-ish is good. Obviously, everything that is free is not necessarily free. What do you have to give up to get some of these things? Well, you either have to, establish an account. So you're giving up a little bit of your privacy. So free-ish is what we're talking about here. So the first one we're going to touch on, and we'll see an example demo of this in a few minutes, is Microsoft Power BI. There's 2 versions of Microsoft Power BI. There's a desktop version that you can download on Windows only. It's kind of a limitation. But there's also a cloud-based version. Personally, I prefer the desktop version. I believe it's a bit better from a capabilities perspective. And ultimately, you then have control of where you save your data. Microsoft Power BI has got 70 plus data sources. It can ingest things from Excel files to JSONs. You can detonate JSONs live in it. It's pretty awesome. Text, CSV. It can pull in stuff live from the internet, via APIs. It's really an amazing set of sources of data. It's got a whole bunch of visualizations. Last count, there was, let me do some math, there are 25 of them that come out of the box, but you can download a whole bunch more of community-built, community-built visualizations. And we're going to see one of those here in our demonstration. You can filter the data multiple different ways with multiple different fields. It's pretty amazing, right? I would say my favorite capability, the best capability with Microsoft Power BI is the ability to ingest data, build your visualization, save it, and then the only thing you have to do is refresh the data and hit refresh in the tool, and you have a brand new, clean, fresh visualization. As I tell people when I've done pen testing and hunting, I'm either lazy or efficient. We'll go with lazy. Power BI allows you to create a visualization that might be the thing that helps you to get the funding from your boss for cybersecurity capabilities, right? And refresh that on a regular basis without a whole lot of extra work, and that's pretty fun. So again, talking a little bit about the difference between Power BI desktop and the service. Really, what you have is lots of data sources, direct Python integration, themes, the whole 9 yards. The Power BI services, right? You can do sharing online. That's really awesome, right? But again, you have some additional limitations. Some limitations that you do find with Power BI is that on the desktop version, you can only ingest about 1 gig of data. The records and rows are limited based on your source and size, right? And it's really hard. One of my things that I really don't like about Power BI desktop is you're not able to save visualizations directly other than exporting a PDF. Now, we all know on Windows, you got the nice snipping tool, all those things like that. So you can get pictures of these visualizations into, say, a PowerPoint presentation or some other graphical presentation, but that's useful. If you want to share the visualizations out of Power BI, somebody else has to have Power BI. Pretty straightforward. A good capability here is you can directly ingest and use Python scripts and R scripts. So if you're truly a big data wonk and you really, really like to do R, which is the data scientist language, you can do that natively in Power BI. And that is a very, very useful tool, especially when you're dealing with large data sets on ingest. So that's our first tool. Our next tool we're going to talk about is Tableau Public. We'll also show you this one. So Tableau Public has a desktop version, which costs money. It has the public version, which is free-ish, right? But in order to save capabilities or save your visualizations and all the great work you do with Tableau Public, you have to save it and it gets put up online, which I will show you. That's pretty good. Interestingly, it has very limited data sources, right? They want to get your appetite excited about having a Tableau, and then they want you to go and buy either their service or the desktop version. That's okay, right? That's the way these things work. Why it's a free-ish capability. When it comes to visualizations in Tableau Public, what you see is what you get. You cannot download new ones. It's all what you have there on the show me screen. And of course, you can do filtering and slicing and dicing. Tableau Public inherently is different than Power BI. Power BI is very much like pivot tables. Tableau Public is more like direct data access. So it's pretty useful. I will say one thing, one of my favorite things with Tableau Public is that it can do native JSON handling and sharing, which is super nice. If you ever get one of those JSON files out there, so the JavaScript object notation files, if you ever get a JSON file that you can't really do anything with, you can probably throw it in Tableau Public and get the data out of it. So that's really, really useful. So you have desktop and public, those two different versions. Obviously, it's limited, right? So again, the public version is limited to 1 million records and rows. It's got very limited data sources. And of course, there's a risk with Tableau Public. You have to save your visualizations if you want to save them and continue to work on them. They end up getting saved into what's called Tableau Public Cloud. Tableau Public Cloud is pretty cool. There's a lot of, if you've never looked at it, you probably should, but there's a lot of, from an open source perspective, there's a lot of folks in various different industries that have built a large number of visualizations that are free and available on Tableau Public. Everything from history to cybersecurity to what's going on with COVID-19 right now. And those are available free to the public on Tableau Public, on Tableau Public online. You can look through them. They're pretty cool. But again, if you're dealing with, say, sensitive data, you may not want to use Tableau Public because you have to save that data out online. Other free-ish big data tools. So some of you have probably heard of Pandas and Jupyter. Pandas is a Python capability. I'm going to show you Pandas profiling here in a minute, which is a really great way to get after data very, very fast. Jupyter Notebook and Jupyter itself is something that you use for data science and building data frames and very quickly slicing through data. That's also good and free-ish. not going to demo that one. Elastic, another great open source-ish capability where you can ingest a whole bunch of data, not just their sensor stuff with their Beats agents, but a whole bunch of data to do analysis on. And then Security Onion, which is great from a big data perspective for security and cybersecurity problems. It incorporates the Elastic Stack now and allows you to get after your large data sets live and online and in real time, which is awesome. So big data. So we talked about velocity, and we talked about variety, and we talked about volume. Obviously, right, if I take a whole bunch of data from a cybersecurity perspective and I throw it at you, and you have to do something with it, you have to do some initial cleaning, right? So when we talk about cyber big data, we have to do that normalization. And right, so if you grew up doing software and grew up as I learned software and coding and all that in college and database work and everything like that there, you heard the terms normalization, right? The first normal form, second normal form, third normal form, and you had to do that, right, to make sure that you could actually connect those really nice relational databases from one point to another point, right? So you could actually do a query and get back the information you wanted. Big data is really no different. We have to normalize the data, especially with disparate data sources, to avoid garbage in being garbage out, right? So there's questions you want to ask yourself. What are your sources? In the case of what we're going to look at today, our sources are going to be packet captures. And that's where we're going to start with, right? And then if I were to take and merge two packet captures, right, or merge a packet capture and say flow data, right, I have to look for common fields in those sources, right? Obviously, IP addresses is probably a good thing to look at. Common fields, right? Is the formatting the same? This is often walked over. Dates are an incredibly important thing from a cybersecurity perspective, whether you're just doing basic network analysis and trying to understand your environment, or if you're doing actual incident response, dates are incredibly important. And if dates are not formatted correctly and you're trying to slice your information, you're not going to see what you want to see. Pivot points are also another key point. If you don't know that, if you don't know how to deduplicate your data and then pivot from one thing to the next thing to the next thing, right, you're not going to be able to normalize your data. And probably the biggest one here to me is duplications, right? Obviously, if I have multiple different data sources that all have some similar data in it, I'm going to have to dedupe that somehow, right? And so that's how we work through this to get there. And our goal at the end is extract, transform, and load that data, or ETL, right? And so the general process that we do is we integrate the data, we transform it, we reduce it, and then we clean it, right? There's a lot of manual work when you're dealing with initial data sources from a cybersecurity perspective. Think of like a SIM, right? If you have a SIM, right, you actually have to do a lot of tuning of that SIM long in advance before you get any real usable data out of it. And so that's what we're talking about when it comes to this big data problem. What we're going to do here in a minute on a small scale, though, is look at how that is done with Power BI and with Tableau and with other tools, specifically Pandas profiling, to show that this can be done on a small scale very, very quickly and at a very, very cost-effective manner, so that you can begin to understand your cyber environment. So visualizing an environment, what did I do? So I'm going to show you some slides, and then I'm going to show you the demo, and I'm going to talk a little bit how we set this up. So you have the internet on the left-hand side there. Obviously, that's where all the bad things come from, because the internet is inherently not a very nice place, right? It comes through my cable modem into my house. I dropped in something called a Shark Tap. That is, it's say less than $200 on Amazon. It is a passive collector that allows me to just have the network pass through, and I tap out and pull out all the information that I need from a packet capture perspective. And that's what we're dealing with here for our data set. I have two networks at my house. I have an operational network where I have lots of devices, and I have a development network, which is split off and managed via a Ubiquiti Edge router for fun, where I do some development work. I do things like turn off the internet and see what happens with devices and DNS and how they call out from an IoT perspective. All sorts of fun and creative things you can do here. But the goal was to show you that all I'm doing here is doing a passive data collection to show you some of the data that you're going to see here. But here's the Shark tap. It's easy, it's passive, and it does 1 gig of bandwidth now. If you buy one of these from Amazon, please don't buy the one that's only 100 megabits per second. You will drop packets. So the 1 gig one is awesome. It's in my toolkit. If I go somewhere on an incident response or a hunt, I bring this tap with me because it is passive. It does not disrupt data flow. It just allows me to collect information. So a very, very useful tool. That is the sensor that was used to collect the data you're going to see today. Talk a little bit about Wireshark. So obviously you could do TCP dump. There's lots of things you can do with Wireshark, TCP dump, WinPCAP, all sorts of things like that. Specifically, I did Wireshark just to gather some information and data to show you what's going on. Regardless of how you do this, Wireshark is my export point for the data that I analyzed in Power BI and Tableau Public. So in Wireshark, it's important to note that what you see is what you get. And on the top there, you see a blue arrow. So that blue arrow points to the fields that I have displayed. And so in the middle there, you see the Wireshark preferences and a bunch of fields. I have a number of custom fields specifically for IP geolocation, which I'll talk about in just a minute. But here's the thing. If I'm going to export data, whether I've used TCP dump, WinPCAP, T-Shark, or Wireshark itself, if I'm going to actually get out of my export all the data that I want, I actually have to display the fields that I want so that I can actually export all of those fields. If I do not display those fields in Wireshark, then my export will not give me everything that I want, and that's an important point. Wireshark settings. So more of this here. Everybody likes maps, as you see there in the screen. That's an actual map generated using, in this case, Power BI to show mapping and locations of IP addresses of data that I collected. So GeoIP data is really, really valuable. You can go to maxmind.com and pull down a free set of GeoIP data and very easily integrate it there in name resolution section of your Wireshark preferences. That is useful. And again, the key thing with MaxMind data is this isn't live data, right? All this is additional data that you're adding into Wireshark's capability from an analysis perspective. So if you like to map out IP addresses, and I know people will say, but IP addresses can be spoofed. How do you know that they're from the location? I don't, right? And I agree that they can be spoofed. However, when you're talking about a small scale analysis of a smaller network or even a mid-sized network with some basic packet captures, right? Understanding that you might have IP traffic flowing in from, say, Russia or other places of nefarious ilk, that may be a good thing for you to do and very quickly understand what's happening in your environment. So we talked about visualizing that environment. So in Wireshark, you can do multiple types of exports. You can export as a JSON if you like that. You can export as an XML file. You can export as plain text. In this case here, for the demonstration, for both of the things I'm going to show you, I exported as a CSV. CSV is obviously a native ingest for both Power BI and Tableau Public. But one of the things that's nice about exporting in a large PCAP to a CSV is it actually reduces the size significantly because you're only exporting the fields that you chose to view. If you view all the fields, then obviously your export is much larger. Obviously, when we're talking about big data on a smaller computer, right, not a big, say, cloud-based system for analysis, right, you have to be careful of your scaling. You want to make sure that you have enough processing power to do what you want to do. What you see right there for some of the initial visualizations I will show you, that's a 9.3 gigabyte packet capture. That was 42 minutes of my home network, which we reduced down to 2.7 gigs for analysis. That's the big data problem we're dealing with. Right? That's 42 minutes of my home network and my kids doing what they do on a regular basis when it comes to using the internet for doing the things that they do. And so I want you to think about at scale your work network. How many gigabytes, terabytes, petabytes of data is actually flowing through your work networks at a time? Right now, a whole heck of a lot. And so this is a really quick, easy way to grab a sample of data and drive through it to see what's happening in your network. So why do we visualize a network in a tool like Power BI? Well, for example, this first visualization that you see here, right, shows that I've got 8.169 million rows of data. So each of those is, so think of almost 9 million records. That's what I'm handling from a big data perspective. The bubble chart you see there is one of the custom visualizations you can pull down with Power BI. And that bubble chart there is literally all of the IP addresses and all of the hosts that are either in my network or transiting or sending traffic into my network. That's a pretty large and tall order to drive through. So we're going to filter this down a little bit. And specifically here on the left-hand side, I was really curious to see what my kids' iPhones look like. And you can see that on the left-hand side there. There's a whole bunch of traffic happening with iPhones and that kind of thing. What was really interesting, though, was I saw a whole bunch of port 80 HTTP, so basically unencrypted web traffic on my network. And I said to myself, that's super interesting. What the heck is that? Well, it turned out that one of my kids' gaming consoles, shall remain nameless, talks out mostly on port 80. And to say the least that I was annoyed is an understatement. I don't understand how a major vendor of a gaming console is still using just HTTP when better than almost 65-70% of the internet right now is running encrypted traffic. Makes no sense, right? And so one of the things that I haven't had a chance to do is dig into that traffic and see what is actually exposed from a data perspective. But it may be something that I end up writing a responsible disclosure for, because that's concerning. And I encourage you, think about this. Do something like this on your home networks, right? See what's actually happening, right? And understand that environment, just like you would do at your work environment, because you never know what's going to be happening. And so I didn't really know that that was happening until I actually did this collection and ran the visualization just to see. Something else you can do with tools like Power BI and Tableau Public are long tail analysis. You can do that very, very quickly. You have destination port here and source port here. So you can see, interestingly, the top ports on my network are port 80, and that's coming from that gaming console. And again, I would not have known that had I not grabbed this collection and then did this very, very quick long tail analysis in Power BI. This is a tree visualization of what was happening in my network. And the vast majority of my network, the top 7 things, are all content delivery network stuff. So you see the Akamai's of the world and the Comcast Edge and some of the other things that you would expect, some of the Amazon stuff. Nothing untoward in my network. What was interesting to me, though, was that Instagram was number 7 in traffic on my network. That's my daughter. She has a number of fan accounts for K-pop, and she does a lot of Instagram, and it's really cool to see how much traffic her little iPhone actually generated in this 42-minute collect on Instagram. I know at the time my kids were also watching YouTube. My son's working on his joining the cybersecurity and IT field, and so he's got a lot of things he watches on YouTube. And interestingly, YouTube is really lightweight and not a lot of YouTube, and that was near the bottom. But again, this is a really quick and easy way to visualize and understand your environment and understand what is in and out of your environment very, very quickly. Using the tree diagram, you can actually slice and dice and get, this is DNS traffic, right? And what you see on the right-hand side of that particular visualization is the info. That's literally all of the DNS queries and the different things that are talking out of my network from a DNS perspective. This would be a really quick and easy way, if you had something odd talking out of your network, to potentially catch like a DNS exfiltration. Lots of easy ways to see what's happening there and very quickly sort through some protocols instead of what you see on the left-hand side of the screen here, which is Network Miner, which I love Network Miner. It's a great tool, but picking through that to pull out some of this stuff and then filter it down based on very specific queries, very difficult with Network Miner and takes a long time, especially for a large packet capture. What we're going to show you is this is very fast when you use either Power BI or Tableau Public. So we're going to do this live. And so we're going to hope that the demo gods are smiling on us today. So I'm going to stop sharing this tab. I'll come back to the presentation in a second, but we're going to look at some tools here when it comes to both Tableau Public, Power BI, and then Pandas profiling. So we're going to start with Power BI. And entire screen. And share. So the first thing you're going to see when this comes online, and should see it now, is this is the Power BI desktop, right? And so initially I want to do is a little orientation. So don't worry about the data. The data here is to show you how quickly, the goal here is to show you how quickly you can slice a large chunk of data with Power BI very, very simply, right? And this is going to tell a story here in a minute, which we'll go through. But what you see here in Power BI is you see a number of things. One, you've got your get datas, you've got data transformation capabilities. In fact, I'll do this. So this is how you sort of get through the data. This is getting data. This is transforming data, visualizations, measures. So a lot of the things you can do in Microsoft Excel, for example, from a formula perspective, you can create measures and formulas and calculations, and it's very, very useful there. What you see here in the middle is your visualization. At the bottom are tabs these are each their own separate visualizations. You have the fields that I'm using. So this is the exported CSV of that PCAP that I talked about. These are visualizations that you can do. You can see these are the standard visits, and then you have custom visualizations. This is how I would actually format the data with the little, looks like a paint roller here. These are all my fields and filters. We're going to work a lot with filters today because this is the value of a big data tool such as this. And so what we have here in the middle here is I've got some text-based fields. I have a count field that tells me I've got, in this particular PCAP of badness, 51,000 plus entries, right? I have a count of source here. So this is a tornado diagram, and this is a custom visualization of a network map. So pretty straightforward. And so you can see here, this looks like a whole bunch of gobbledygook. And you say, man, Brad, how is there anything useful or valuable in all this? Well, let's find out. So under the covers, there was an attacker, probably me, that did some bad stuff in my network. And so this is how you would catch something like this or potentially see something like this, right? And so what we're going to start with is simply grab our protocol field and drop it into this filter here. Now, what's really neat is in basic filtering, I can walk through this list, and I'm sorry if I'm going a little fast, but just show you there's a whole bunch of protocols in here that may be of interest. But as I walk through this list, I come to a stop point and say, man, there's ICMP, ping, right? So that's cool. So I'm very curious who's pinging stuff in my network, because usually I'm the only person pinging stuff in my network. Well, let's see what ICMP tells us. Wow. So what that has done now, it shows down and filters me down to just the hosts that we're dealing with pings. And we can see that I have this one host here, 192.168.1.40, that has sent 110 pings, right, to various hosts, to Google, it looks like a router, and it looks like to some individual hosts in the network. And you can also see that visualized there. Well, that's super interesting, right? So that gets me thinking here, what else is happening in my network that I'm not aware of? So we're going to go ahead and take the protocol filter off, and you can see the visualization resets itself. And now we're going to do something here. We have a tab, or one of our fields from our Wireshark PCAP is called info. And now info is listed here, as you can see in this box. Info is just information. So think of that information tab that you might see in Wireshark when you drill down into an actual packet. That's all listed here. So when I see pings, I get a little concerned that maybe there was some additional scanning going on. And so, you know, attackers like to use Nmap, which is one of my favorite tools. So what we're going to do is we're going to filter specifically. In fact, what I need to do is go to the advanced filter. Advanced filtering is nice because I can be very granular in my searches. I'm going to do a SYN. So basically what I'm going to look for is I'm going to look to see if there was any SYN scans in my network. I'm going to apply that filter, and sure enough, there is SYN scanning in my network. And I can see that this traffic is, again, coming from this host, 192.1.40, to the two main hosts here, 1.1, which is probably a router, and 1.4 or 1.42, which is probably a host. And so this is really interesting to me because now I'm seeing stuff that's concerning. I have pings in my network. I have SYN scans in my network. Now I'm really, really concerned that there's something else going on that I should be looking at. So let's look at that a different way. So we're going to look at something called a chord diagram. So a chord diagram is a really quick, easy way to map and show flows of data from one point to another. In this case, from multiple hosts to other multiple hosts. And so what we're going to do is we're going to do the same big tick filtering. I'm curious. I want to confirm that that 1.40 host is the culprit in my network. So we're going to grab protocols again. We're going to drop it and filter on the page. And we're going to simply go back down to ICMP and see, And sure enough, here is the host that 1.40 has been pinging. Google, obviously probably figuring if it's connected to the internet. It looks like to be some sort of router here, another router here, and then an actual host. So that's very interesting. So again, let's do that same thing and look at those SYN scans using that info filter that we did. Right? So again, basic filtering is nice if you've got a really straightforward list. If you don't have a straightforward list and you have a bunch of, say, a large set of text that you need to filter through, and you want to ask specific questions of the data, this advanced filtering is the way to go. So again, we're going to filter this down to look at the SYN scans. And there it is. You can see that, yes, I can confirm that 1.40 is the one that is scanning all of those networks. And so this is important. Here's 1.40 scanning 1.42 and 1.1 and potentially other things there. So this is very concerning that we have all these SYN scan happen in the network. So it really seems that this 1.40 is poking around somewhere in the network. So let's look at another visualization. We'll look at sorted time, right? So again, it's really interesting to see when you look at these types of visualizations, right? So again, this is a time sort. So one of the great things about having good time fields, like we talked about earlier, is it's very easy to sort that data. I like to think of networks as organic. And as you can see, there's a lot of organic traffic potentially happening in this network. But I already see, just very quickly looking at the visualization, these little rainbows, and you might see them here. There's another rainbow here, and there's another rainbow here. My guess is that's the SYN scan, right? And so if you ever wanted to see what a SYN scan looked like when it comes to just straight data, let's look at it. So we're going to, again, filter down on our SYN scan. As we filter down, there's those two rainbows right there. And I know, having done some additional research on this, right, that our first SYN scan, or one of them anyways, appeared right there at 11:57 a.m. And as you can see, I'm going to walk this a little slow here. You can see the SYN scan where the attacker walks multiple ports. There's destination port 1011, destination port 2492. And so again, trying to figure out what's going on here. But there's other SYN scans. And so there was another one at 11:58:42. I'll show that one as well. And there it is, right? And so again, you see this SYN scan, right? So clearly there's an attacker looking to find stuff in the network. And so I did notice something interesting when I was doing the analysis of this particular PCAP. Let's go back to protocols real quick. So we're going to filter on this page. And specifically, I noticed FTP and I noticed Telnet. Obviously, two protocols that should not be running in anybody's network and are also very scary. And so you can see here, right, at one point or another, right, these particular things were occurring. So right now, if I click on this here, that's where I was seeing Telnet traffic. Here's where I was seeing FTP traffic. And what exactly am I really seeing here? Well, the truth of the tale is in the info tab. I can see here that this is an attack of some sort against that FTP server. And if I continue to scroll down, I see the thing that's the real problem here. I see VSFTP 2.3.4, which is an extremely vulnerable FTP server that should never be running in a network, but it is in this case, right? And obviously, there was a directory or looking at directories in this. And then future stuff probably used information to do a pivot and move into Telnet and then do other things. And so this attacker was really loud and not very smart. So if you really want to know what happened here, the bad guy, the attacker, that was me, grabbed the Etsy shadow file and stole it to do other badness across the network. And in fact, if you remember, that 1.1 is an actual router, and that router was actually not exploitable, but was easy pickings because the default password was set. Now, I did all this for demo, but hopefully you got a feel for how quick and easy this was to slice through literally almost 52,000 records, right, to get down to what was actually happening. And again, this was all predicated and based on the fact that we did data collection, we did good data display in Wireshark before we did the CSV export, right? And then we did the data slicing within Power BI. So some things with Power BI. I did no normalization at all. I didn't ingest another data source. I didn't do any normalization. I took what the data I had was, and I allowed the backend process of Power BI to just do that normalization, which makes it really simple and pretty straightforward to use. So let's look at that in Tableau Public. And Tableau Public is a little different. And that's incredibly important to understand. Tableau Public is, because it doesn't do like the pivot table work in the background like Power BI does, it does direct access with the data. So it's a little bit different. So let's take a look at that. So this is Power BI, or this is Tableau Public. And as you can see here, for ease of time, I've already shown you, here's one of those scans going from 192.168.1.40 to 992.168.1.1. And so this is the scans. That's pretty easy to catch that. You can see that, right? But one of the things that's interesting with Tableau here is I can do the exact same thing, right? And I can very easily look at this data, right? And so this is all of the different, and this is nice because this is all of the info packets associated with each of the different hosts. And as you can see here, here's the SYN scan. Very, very easy to see. You've got multiple ports, you've got SYN and everything like that. But let's do something fun for just a minute here. So again, we can filter in Tableau Public just like we do in Power BI. Same kind of thing. I'm going to grab the protocol. I'm going to drop it in my filter. Specifically, I'm very interested in that FTP because that is super interesting. So here it is right here. Here is the FTP connections, right, between 1.40 and 1.42. And as you can see here, here is what happened really. Again, it's throwing some passwords at it. Eventually, it was compromised because of this exploit right here. And again,
Hey, Brad, can you hear me?
on the source. And so you can see here, it's pretty straightforward from a filtering perspective. I'm going to say none. And really all I want to grab is my attack box. And I'm going to say apply. And that's going to filter me down to everything that the attack box was doing. Pretty cool. The other thing that's cool with Tableau is that you can build dashboards. And so now you can see I have the attack box mapped against what was going on here from a dashboard perspective, right? Really easy to do. Now, as I mentioned, Tableau Public is one of those things that you have to save the data online. So here's the data itself online. And as you can see here, again, all the sheets are there. It's a web-based interface. It's not great. It works well. You can actually, if you own the graphic, edit this visualization online, right? So again, this is a quick, easy way. If you've got, as an organization, some really cool data you want to share with the public, this is a really easy way to get that out there. Doesn't cost you much, except for, again, some details about yourself. Pretty cool stuff, right? Definitely some value here. But again, if I was doing this and I have a number of visualizations in my profile that are pretty interesting, IoT ways, stuff like that, right? But again, keep in mind that risk that we talked about earlier with Tableau Public. If you share this data out there, that means it's available to the public. You can hide the data on Tableau Public, but again, how much you trust, it's just something to think about, something to consider. So we're going to go ahead and close both of our instances of Tableau Public. And no, I'm not going to save changes. Okay, so let's go back to the presentation briefly. So the demo gods were nice to me today, so hopefully they continue to be nice. So let's talk about Pandas profiling real quick. So Pandas profiling is an automated quick way to do data analysis using Pandas. Pandas is a big data science platform capability. It's integratable with Jupyter Notebook, other things like that. It's part of the Python family of capabilities. Really, really awesome little capability. But Pandas profiling, again, lazy or efficient, takes the hard work out of actually building visualizations and puts the power into your hands. You can download it from PyPy or GitHub and get that installed and running. So what I want to do is I want to show, and I'm going to move this down so I can share that screen. I'm going to show you what that looks like. And it's pretty cool because, again, I like to, as a cyber defender and as an analyzer of data, if I can find tools that allow me to get to what are the things I should look at as quickly as possible, right? Pandas profiling is one of those things that I'm going to use. So let's hop out of the presentation real quick. And let's go to Pandas profiling. And with the magic of modern technology, okay. So here's Pandas profiling. This is a Pandas profiling report. I'm not going to bore you by running Pandas profiling, but I will tell you that when you run Pandas profiling, it can take a set of a million records and slice through it in about 6 to 8 seconds. So incredibly powerful tool, incredibly fast, right? And what it's doing is just going through and using some basic data science principles to look at your data. And so what I want to show you here is, I'm going to toggle some details here. Interesting, right? As we saw in Power BI and Tableau Public, 1.40 stood out, right, as the culprit. It stood out very, very quickly. This would have been super useful for me if I didn't want to sort of mull through a bunch of data. I just wanted to take a CSV or a JSON or a text file, throw it at Pandas profiling, and figure out where I should start from my research and analysis perspective. So that's pretty cool. Another thing to look at here is we're going to look at the ports, right? So again, we're going to toggle the details, right? And we're going to look here at common values. And I start to see here, oh, here's port 23. Why is there a telnet happening, right? And these are all some of those values that you can pull out of the data very, very quickly. If I'm interested in protocols, right? Again, protocols here, I can see the list of protocols and those common values. And I see things like telnet. I see things like GQuick, all things that are probably not supposed to be in my network if I've done good network security. But the long story short here is that if you have a large set of data and you have no idea where to start looking for something, right? Take Pandas profiling, throw that data at Pandas profiling, and go from there. It's a pretty useful tool. Okay. Go back to the presentation. All right. So let's talk a little bit about log analysis in Power BI for incident response. Here's your bonus, right? So we're here. If you're aware of the cybersecurity framework, it's a great framework to look at and reference if you don't have good cybersecurity or you just have a nascent cybersecurity in your organization. NIST products are great for a starting point for you to get from good to great when it comes to cybersecurity. And so in the cybersecurity framework, you've got 5 areas. You've got recover, identify, protect, detect, and respond. We're in response, if you can imagine here what's happening with what we're going to talk about. So it's a pretty straightforward process, right? I've had instances in incident response and hunts where I've been given a chunk of data as a Windows log. Blah, here's your Windows log, Brad. Go find the point of compromise. And using Power BI and a couple of clues provided by the people that provided me the data, it was fairly easy to ferret out and find where the point of compromise was based on the log itself, the time, and then the actual executable that occurred, right? And so Power BI is a great tool if you're given Windows logs and you have nothing else to do. And again, who wants to look at a bunch of Windows logs, especially if they're good Windows logs, which we'll talk about in a second? Who wants to look at a bunch of Windows logs and wonder what the heck's going on and have to filter and scroll? I mean, that's no fun at all for anybody. So again, Windows logs are great. Using the Windows Events tool, you can export those as a CSV, just like we did with Wireshark. You can ingest into Power BI, and you can find evil in the logs. But first, we have to talk about a couple things. So good incident response with Windows logs and Power BI starts if you're doing good Windows logging. I bring this up because it's incredibly important. Windows default, and it just is what it is, comes out of the box with very little logging turned on. And that's okay, right? But as an organization, even at your house, right, if you're, and many of us are working at home, so paying attention to what's going on in your home network is incredibly important. But I will tell you that understanding these Windows logs, right, and what you're actually logging is super important, right? And so you can do stuff at the command line via the audit poll tool. You can turn things in the group policy editor, right? But I encourage you to look at all of the different things you can turn on in Windows logging and turn some of them, if not all of them, on. They're very useful. The ones we're specifically going to look at that I turned on the Windows machine that we were dealing with here for this demonstration, right, was detailed tracking. So specifically looking at process tracking, process termination, and token writes. Additionally, I turned on command line logging. So just from an aside, if you're not doing command line logging in your environment, whether it's Windows or Linux, but Windows in particular, right, I will tell you that threat actors today, if they get into your environment, have you dead to rights. You will have no idea and have no visibility of actors pivoting, right, or escalating privileges or moving around in your network. You just won't see it if you're not doing command line logging, right? And I'll show that here in just a second. But command line logging is incredibly important. So if you're not doing that, and if you take anything away from this presentation, figure out how to figure out if you're doing command line logging, and if not, make sure you turn that on across your enterprises. So let's talk about the incident that occurred here. The user of the desktop in question and the local defenders, provided me with some basic information about this particular event. One, apparently there was some design data sitting on this desktop that probably shouldn't have been sitting on the desktop, right? And at some point on the 11th of June, the data disappeared, and this note, "Thanks for the design data. I love other people's intellectual properties. Happy Thursday," showed up on the desktop. That's concerning. And then when they pulled some information about what was going on this particular host, they noticed a number of things. They noticed a bunch of console hosts and Python running and PowerShell and Command Shell and Python. And then this super concerning thing here, python-m http.server1234. We're going to come back to that in a second, but I want you to remember that, because that is super concerning, right, when you see that. But that's the only clues that I have. I was given the Windows log. Here we go, right? So let me tell you what the red guys were doing, because this is the back end that you don't see sometimes as a defender, right? So the red team in this case, right, had earlier in the day phished the user of this desktop, right? And they downloaded an executable. They ran that executable. Nothing happened when they watched it, but it opened up a port on that host. The bad guys stood up a interpreter listener and grabbed a shell and were on the box, right? And they ran that command right there. And so if you're not aware of what that command does, is Python, both version 2 and version 3, have the ability to create mini web servers, right? So Python -m http.server1234 basically opens up a little micro web server on a host, right? And in this case here, it opened up on the desktop and allowed, you see the design data.txt there, right? Allowed the threat actor to basically open a browser and download the design data.txt and pull that file. And then they did a little work here and they echoed this and put that notepad document on the desktop to poke fun at the user who clearly isn't doing good security. So this is that back end side of things, right? Because again, it's important to understand that threat actors will use whatever tools are in your environment against you. In this case, the threat actor used Python against this desktop. Okay, so let's take a look at what that looks like in Power BI. And the demo gods are going to give me one more go today. Let's see here, entire screen. Okay. All right, so again, same thing with Power BI. So what we're going to look at here is some interesting stuff. So this is very quickly, and so so to give you a little background here, right? This probably looks pretty easy, and once you understand what to do with Power BI, it's relatively simple, right? But it's also easy because I have some knowledge of the data that I've brought in, right? If I was John Q. Public and I had no idea what was going on and you just gave me Power BI and some data, I probably wouldn't be able to figure it out. I have to know something. So I have to know something about Windows event logging. I have to know something about the actual underpinnings of how Windows works to be able to cull through this data and understand what's happening. incredibly important and incredibly valuable to have that knowledge, right? And so a tool like a Power BI or a Tableau Public in the hands of a trained cyber defender, right, is incredibly powerful, right? But not as powerful in the hands of somebody who doesn't really know or have that experience in cybersecurity or whatever particular field of work that they're in. So really quickly, we're going to filter this thing down. So we've got some stuff in here from the 7th of June. I don't really care about that. For whatever reason, this host was offline till the 11th. So really what we're going to do, we're going to start here, and we're going to do some stacking, which we did not do before. So we're going to filter on this page, and we're going to stack. We're going to put a day in here. And so I know, and I'm going to go to just basic filtering for now. I know that the incident occurred on the 11th. And so now we filtered this down to 1,416 events. And now what I'm really curious about is I'm specifically going to look at Windows Event ID 4688. That's process create, right? Because anytime a process is created in an environment, if I didn't create it, I think it's suspicious. I'm paranoid like that. And I think that's probably not a bad place to be. So really simple. We're going to go again back to the basic filtering, and we're just going to pare this down to 4688. And as you can see, right, very simple, I'm paring down the data that I have to go through. And that's the value of a tool like this. I can take a large data set based on some initial information and pare it down to something useful. So as you can see here, we have process command line and then all this gobbledygook for process command line details, right? I will tell you that Windows event logs, right, sometimes come, and this did take a little of manual data normalization, right? But again, I'm really just going to go after specifically some clues that we had. So just like we talked about previously, we're going to use those command line details. Again, that is basically a free text field we're going to search through. We're going to go to advanced filtering, and we're going to look for that Python command, right? We know that the bad guys use Python on this box. Simple. Apply the filter, and we have 4 events. We see, it looks like they established 2 servers. That's interesting, right? Actually, 3 times potentially. And it looks like they just tested whether Python existed or not, right? So that's interesting. And so what you can see here is that we know some stuff is going on. That seems interesting. So let's look at that when it comes to time. So remember, we've got some times here. So at one point, let's see here. So we're going to look here. So it looks like they, around the 722, they tried to see if Python was there. Around 725, they tried to, they launched a server. They did it again at 722. They did it again at 728. And this is the one that worked for the data exfiltration. So let's look at some timings. So again, times are very important when it comes to slicing through data. So again, we're going to go ahead and we've already done this. And so what's interesting here, so let me talk real quick about filters. Filters are cool. You can filter on a page. You can filter across all pages in Power BI. Or in the case of this one here, I have a filter on for the day, which just gets me down to the 11th from this display right here, right? You have to be careful with filters because if you filter the wrong thing, you might not see the data that you want. So just be cognizant of whether you're filtering on a visualization, filtering on a page, or filtering across all of your pages and dashboards. Okay, so what we're going to do here is we're going to simply pare this down again to that event ID of 4688 because that's our starting point. And so here's 4688. And so that doesn't necessarily help us very much, right? But it gives us some feel of what's going on. So we know here's all the events that were created on this box on the 11th around the time or somewhere around the time or where we have this Windows event log from. So a couple of things that are interesting here to me is I want to, again, look for that Python command because I'm sure that there's happenings with Python, but I'm sure there's other things happening. And if you remember from the clue we had earlier, we saw some command line stuff, some con host, and we saw some PowerShell. So remember that, right? We're going to look at that here in just a second. So same kind of thing. We're going to grab those command line details. We're going to filter specifically initially just on Python. We're going to do that in advanced. And there are the Python events that we were expecting to see. And there's the Python event at 728. That was where the data exfiltration occurred. So let's look a little bit differently. So I'm going to go back to basic filtering. And so I'm going to look for Python in general. And so you can see here that I'm just going to grab all the Python things toward the bottom here because I'm curious as to what's happening. Okay. Remember, we said PowerShell. Let's look for PowerShell. Oh, look at there's PowerShell. Well, let's look for command line. That's interesting. So we're getting a bigger picture here now by simply stacking some data to see what is going on when it comes to this particular machine. I'm going to keep stacking. Interesting. So we're going to come back to that here in a second, and we're going to pop this out and do a little razzle dazzle. The other thing we saw was what we call was conhost, and that is run, and that's being run in the background. And I believe, if I remember correctly, it's force V1 is what I'm interested in, because that's forcing that to the background so you do not see it. Ah, now we see more of the story. Okay, so right now, this doesn't really help me a whole lot, right? All I see is a bunch of 4688s. And like I said, Power BI is useful because I can very quickly slice out and pull out data when I want to see it, right? So what we're going to do here is we're going to change our legend. So I'm going to take our legend of event ID off, and I'm going to take and drop the command line details in here. Now, granted, it's not going to be very pretty, but it's going to tell an interesting story. Okay, so now what do we see? We see our threat actor looking at different things. And this is probably right here where the threat actor got onto the box, right? Very useful. And when we talked about that interpreter shell, right? This is it right here. So you're seeing the threat actor. Here's where he opens up a command shell and then goes off and does some other stuff. And again, here we see additional things happening. But what's really interesting here is this part. Here's where he checks to see if Python's running, right? Still in the background of that shell, right? Here's again, he opens a command exe. He opens up the server here. Interesting, right? Here, right? Again, but it apparently doesn't work, right? Does it again, right? So that's this. This is our command. There's the 8080 doesn't work. But now we see the attacker do something interesting. He opens up, if I can get this to stay on the screen, PowerShell. Then he opens up, looks like, a command prompt. Then he launches the Python, which appears to work, right? And then over here, he's still in that command shell. So what you're seeing here is just by some simple understanding of how the back end of, say, Windows event logging work and how some of the attack vectors work, it's very easy to take this data, right, and slice it out into something valuable. So now what I understand is that I have some ILCs to hunt for, right? I know that the threat actor, right, is operating in the background. I know the threat actor is using either command prompts or PowerShell, and I know he's using Python, right? And so again, he's doing remote shell access, right? How did he get that remote shell access? We talked about it either. That was the phishing that happened, right? And so again, easy to pivot through a large set of data, in this case, 24,000 records from Windows Event Log, and get to the heart of the story as to what was actually happening. All right, so let's go back into our presentation. And here we go. So log analysis for Power BI when it comes to Windows logs and for incident response. Things you should always care about. We talked about process creation, process exit, those kinds of things, right? You need to know your networks. You got to know your users. You got to know your system. You got to know your data. You got to know that entire, when you think defense in depth, or if you think in the concentric circles of multiple surfaces, you got to know all of that, right? But in the case of this Windows machine, right, I couldn't identify an important thing, the actual data exfiltration. Why? Because I only turned on a portion of Windows logging, right? And that's a big lesson here, right? And you can see what's on the screen here. This is all the different categories of Windows logging that you potentially can turn on, right? Per your organization, per your home network, if you're working at home, these are things you should turn on and look at. You should pay attention to a lot more than just the detailed tracking of process creation and destruction. If you're not paying attention to your networks, just like we looked at earlier with the PCAP of badness, or in the case of these Windows logs here, where we also saw some badness and evil, if you're not looking and using all of those tools at your disposal, and oh, by the way, doing that from a risk-based perspective, right? I'm not saying go out and turn on Windows logging on everything or all Windows logging on all your devices all the time, right? You need to think about what is your risk posture, whether you're at your home network, whether it's your business network, whether it's what your kids are doing, any of those things. You need to think about that stuff, because this is how what attackers are counting on, right, is that you're not going to actually do that. you're not actually going to turn that stuff on and pay attention to it. That's what they're counting on, right? So make yourself a hard target and help to protect yourselves and your organizations by doing some of these basic blocking and tackling from a cybersecurity perspective. So I got a list of resources here for you. You'll obviously see those there. You can just Google, Power BI, Tableau Public, Pandas, Wireshark, Elastic, Security Onion. All of these are great tools out there to use when it comes to cybersecurity, when it comes to taking, some of that data that, man, you say, man, I got this stack of data, I don't know what to do with it. Well, here's hopefully some tools that'll help get you to better when it comes to understanding your environments and your data. So before we close up and I take questions, I'd like to thank ISSA today for having me. It's been a lot of fun. Hopefully you got something out of this. At the back end of this, you'll see my contact information. I have multiple contact information to multiple organizations that I do and I work for and do stuff with. You're welcome to hit me up and ask questions if I don't answer your questions directly here. Because again, big data when it comes to cyber is a challenging and interesting topic. I have a lot of fun researching it, and I've done so much of it over the last few years that it's become sort of second nature to be able to slice through information like this. So with that, Teresa, I'm happy to take any questions that the group might have.
All right. Well, thank you, Brad. This is really, really fascinating. And I can definitely see the application of it from a cybersecurity perspective. My question to you would be, if you are just thinking about starting with this, try and think back. Might be difficult before you became how you started. What is the very first 1, 2, 3, 4, 5 things you would do?
So the first thing is you have to collect the data, right? So you have to have a means to collect the data. And I showed you, like, again, I have my Shark taps for as a sensor, right? But you could just even collect data off of your Wi-Fi network with Wireshark or TCP dump or some tool like that. That's step one. You have to have data to start with, right? And then after that, you can then begin to pick a tool that you want to use. Some people really like BI. Some people really like Tableau Public. It just depends on what they're comfortable with, right? Honestly, if you don't know anything else, I would grab Pandas profiling and then throw your data at that and see what comes out. And then that might clue you into, oh, I should throw that in Power BI because I'm looking for a very specific visualization.
Okay. What if you are very novice at it?
So if you're very novice, if you're very novice at it, right, I would say download Power BI, grab an Excel spreadsheet, right, and put some data in there. Like a fun thing to do if you have no experience at all is most banks, you can download your financial record set, like your account information, right? It's lots of data there, right? You can download that as a spreadsheet or as a CSV. Stick that into Power BI and see where you spend your money, right? That's a fun way to get very, very quickly into what you can do with these kinds of tools.
And for any of these tools, do you have any concerns about leaking data? I mean, if you pull it down on your desktop, if you use the desktop version, you're probably okay. But obviously going into the cloud has some issues.
Yeah, no, absolutely, Teresa. Obviously, I'm a big fan of the desktop version because I can save everything locally. It does do the basic, sharing back to Microsoft as far as usage, but it doesn't, like Power BI, for example, doesn't share, any of the data that you're processing. Tableau Public, though, that's different, right? Tableau Public, if you want to save your really awesome visualizations in Tableau Public, you have to save it to the Tableau Public cloud. And obviously there's risk with that. Pandas profiling is a local tool, so you don't have to worry about that.
Okay. All right. That's very, and one more comment I have, because this is something that I'm kind of passionate about, the whole IoT and putting wireless on your refrigerator and now and your dryer and your, at what point should we stop doing that? This is just very philosophical. Or at what point do we force all of the device manufacturers to build it with security in mind?
That's an excellent question, and I'm gonna tell a little story to illustrate my frustration when it comes to what we're seeing in the industry, especially with IoT, Internet of Everything type devices. So before I deployed out to Fort Meade about a year and a half ago now, our printer died. Now, I didn't like that printer anyways, because that printer had its own set of problems. But so my wife's at Target and she says, hey, the printer's dead. I'm going to get a new printer. So I quickly jumped online, looked at something, said, okay, grab that one. That's fine. So she brings the printer home. And I put it on the network, and I'm the cybersecurity guy. What's the first thing I do? I decide to poke holes in this printer. And what do I find? I find a years out of date Linux kernel, and this is a new printer. Okay, so a years out of date Linux kernel. It's running a web server, right? It's running port 445 SMB for easy sharing with Windows. It's running Linux printing and a whole bunch of other stuff that I'm like, why is my printer doing this? And the question I have is, why did the printer come with all that stuff on, right? I'm a firm believer that the industry, and we as cybersecurity professionals and practitioners, right, need to start talking about this, need to start talking to manufacturers and having those conversations with them to say, hey, when you deploy stuff like this, give the consumer the option to turn on what they want, right? I would prefer, for me personally, if that printer had come with everything turned off, with the instructions telling me, hey, if you want to be able to print on wirelessly, here's the things you need to turn on. And oh, by the way, here's the risk that goes with that, right? But we have this concept that everything needs to be convenient, right? And that creates holes in security, right? Because literally my fridge, and for crying out loud, the stove has got Wi-Fi on it, right? None of those things are connected to my network. None of them, right? Because I don't necessarily, and here's the thing, it's not that I don't trust the device, right? I just know that the data is going to go back somewhere, right, to a server in the internet that I have zero control over, right? That could be easily compromised potentially by a threat actor, right? And now somebody can do something to my devices, whether I want them to or not. And that's a very concerning thing. And I think that consumers as a whole, right, I think we owe it to society in our practice, right, to start telling consumers, hey, pay attention to what you bring into your home networks. Pay attention to stuff that you put on your home networks. The gaming console in my house, I'm still annoyed about that. That was a bit shocking to me, right? But I don't, again, illustrating the point that you don't know what you don't know until you go looking. And what concerns me is like how many businesses, right, don't have significant security controls on, say, their networks, right? And they've got, say, employees that have brought in say like an Amazon Echo or some other smart device, right? Again, they're cool, they're convenient, they're great, but they're on your network, and do you really know what's on your network, right? And that's the point in this discussion.
Yeah I think we could actually go deep into that, but I appreciate you sharing your feelings about it, and I 100% agree with you. So with that, I think we are out of time, but I want to say thank you so much, Brad, for this.
You're most welcome.
I really, you've got me interested in looking at my home network through this, and it's a great place to start with all of this. So again, thank you for spending the time. Thank you to those who have been watching this, and we appreciate everybody spending their time, and look forward to seeing you guys on more events. So have a great day.
Thank you.
Take care.
Bye-bye.
Bye-bye.
Excellent job.